Start Camtasia, that's the one I do. Hey everybody, it's April 25th, 2022. This is the second to last week of the semester before finals at College of the Sequoias. And this is Computer Science 1, Introduction to Programming. Today we're going to start a new module. This module is on sorting, and we're also going to look at separation, and which leads to the very idea of object-oriented programming. So we've done this semester, a lot of our files, everything has been in one C++ file. And I've been trying so hard to get everybody used to the idea of doing prototypes above. This is our file from last week. Clean out some of the stuff we don't need. This is our file where we did the tele on Wednesday. We got our prototypes on top, and we come down below, and we got a lot of implementations down below. And this file here is 250 pages long, or not pages, lines long, and it's relatively short for a real project. We obviously didn't finish in it. There was some more stuff we could have done, but it was also just televisions and didn't include all the different types of brands and everything. So it wasn't a complete project, but it's already long. Picture programs that are 3,000 lines of code, and just trying to find what you're looking for. That's what my graduate school project was like. And my program was 30 pages printed out, which is, I gotta say, it was around 3,000 lines of code. I'm estimating. I gotta pull down. Look, I gotta bring it, upload it one of these days, bring it back out. It's on a hard drive somewhere. But that didn't even include all these libraries and all these programs that are attached to, or subprograms, subroutines, libraries and stuff. It was just my main. My main was 30 pages long. And that's how some of these projects get. And you don't want to, and that's just the main. Now tack on all the libraries and stuff that were hand developed. If we were to put it all into one file, you're looking at hundreds of thousands of lines of code. It is impossible to look through and find what you're looking for, find an error or anything like that. So we, as a society, programmers learned how to break this stuff up into objects, and we're going to save objects as different little files, and then we load the object as we need them. A common way to do it is with classes or structures. They are pretty much identical. The only real difference between a structure and a class is structure defaults to the public setting and class defaults to the private setting. Private setting is more preferred for object-oriented programming because no one wants to see how the sausage is made. You want to know what you're getting, what to put in, and what you're going to get out if you put it in. But you don't care what happens in between. Like, I don't care what happens when I'm playing Elden Ring and I start casting my spell. All I care about is that it chooses the right spell, it shoots the spell, it hits the target, does the damage, and it kills it, and that's it. I don't need all the script. I don't need to see all the program for how my character moves, the animations for the staff waving, the animation for the monster charging at me, it getting hit, the spell effects. I don't care about any of that shit. I just want to know, does my spell connect? That's how programming is. That's how they program. So everybody does these little assignments, makes them all, and they put it all in together in one big project. That's what we're going to work on doing here. So what we do is we create, let me bring out my picture, make a picture. Right now, we've got our big file as, we've got our includes up here. We've got our prototypes here. We've got our main. And we've got our implementations of functions and methods. And up here we have classes, structures, stuff like that. The reason why I push the classes again is it's got the privacy setting. It defaults to private. Everything's done that way, and you have to tell it to make something public, which is excellent. You don't want stuff changing. What we're going to do is we're going to break this off. We don't want all this extra fluff. All I want is my stuff to be a main file. And I will include what I need to, like do some includes that are necessary. And I'll put any implementations and stuff or functions that I need in here that are not part of a class structure. But what we're going to do is we're going to take our prototypes for classes and structures, and we're going to put that in a header file. And ideally, you use the name of the class or structure, class name .h. And you're going to, we'll do this all in a second. And then we'll do the same thing. We'll take the implementations, we'll put them in another folder, and we'll call this one, this is the resource file. And we're going to call this class name.cpp. Okay. We will put all of our includes that we can stuff up in here, anything that is needed to run the class. Include stuff needed to run the class. And nothing else. Anything else will go in the main. The idea here is we will have at the end, we will have a class.h and a class.cpp that we can share with others, and they can use the plug and play it, put it right in their code, reference the header file, will document all the stuff. We'll put our documentation and descriptions up here. And all the knit and grit is down here in the resource file, the actual program. But we'll have the prototypes up here so they can see what goes in and what comes out. And if we use good naming techniques, it's obvious what it's being used for. But sometimes do some commenting as necessary so that it's easy to understand what this program does. This is why, this is the big why we push, Redden's going to do it too when you take C++ or CSCI 2 with M, why we push no couts in functions, methods, except for the display ones, except for display or print. That way, we can take and separate our file into 3 files. We can share it with the rest of our team, and it does exactly what it says it does, and it doesn't do anything else. Do I want to be playing Elden Ring and whoever did the spell decided to do a cout that says, guess what, your glintstone spell strikes? Do I need text like that appearing on the fucking screen? No. I don't want any of that. I don't want anything disrupting. I just want to know when I do the spell one, the input button is hit and the out comes the damage. That's pretty much what's going on. I don't need anything else going with it other than the animations, and that will reference another thing. But no, I don't want any text. That's how every program is. We don't want extra junk unless we assign it. So no couts in the functions or methods, except for display or print ones, because then they know what they're getting. So let's show you how to do that here. Does everyone understand where we're going with this? Are we good with the reasoning here? I'm going to do it on what we did with the television last week, and then I'm going to show you one where we got more than one class. One of our students has already done labs 10A and 10B. They have an excellent 10A. I'm going to do 10A in class. I'm going to separate the student's assignment in class. to show you multiple projects like that. And let's just get started. So this is our tele one. We made this on televisions. It did brand names. It did screen sizes. It did resolution. It did refresh rates. It did SKUs for selling it like Best Buy or shit. Is Best Buy even open? Yeah, they still have Best Buy. Target, Walmart, Amazon. We had a little flag for smart TV. Now we want to separate it out. This is kind of long, and I don't want it all long like that. So if you can't see your Solution Explorer where in your program, if you use Visual Studios, and you want to see it, click on View and click Solution Explorer, and it'll make it appear. What we're going to do is we're going to find our class name here. Our class name is Tele. And I'm going to make a header file. I'm going to click Add, New Item on the header. And I'm going to give it the name of the class. I'm going to choose the header file option. I'm going to come down here and name it tele.h. We're also going to make one in the resource file, a new item, and it'll be the same thing, but we're going to do a C+ or C file here, tele.cpp. So let's put these in the order I have them up top. My sources over here. I can click on it here. Like you can switch between the files by clicking on the Solution Explorer or doing it in the source or up top up here. I am going to take my class prototype. Look at that. We did a lot of little methods in there. And I'm going to Control X, come over to Tele-H, and below the Pragma once, I'll tell you what that is in a second. I'm going to paste that in. And then I'm going to come over and I'm going to do the same thing with my implementations. And I'm going to put these in the resource file. So I'm going to come over here and I'm going to grab all these that say Tele. I don't want any other ones, just the Tele ones. But that's all we had here. I didn't even have the rerun method. So all I've got is Tele methods. I'm going to come over here and I'm going to put that in my C++ file. So as we can see, we got a lot of errors right now. Even the C out is an error. Okay. So the first thing we're going to do, let me explain this Pragma once now real quick. Pragma once makes it so libraries only get loaded / compiled once, even if they are listed in multiple folders or multiple files. So I can come in here. I see I need a string because my string thing's highlighting. I'm going to say, I'm going to put my include string here. And that should fix up all the string errors. I'm going to click save. Why is that not working? C standard library, baby. I got it. Oh, there's my classes. Need that in there. It's two identified. They're right there. And I know we have some C outs in here because of the display. I'm going to put using namespace std in. And C outs also need to go to the IO stream, so maybe I need to include that. There we go. Now everything's looking good. I don't see any red over here on the right, but I'm going to scroll down and just look for anything with red that's underlined. Okay, I've included everything I need here. In CPP and in the source file, what we're going to put at the top is we're going to include our header file. And I'll show you what happens if we try to do the brackets like that. It still has a problem. It doesn't like the brackets. Will it take the brackets without the H? No, it won't. These arrowhead brackets are for all the standard stuff that C++ does. When we have custom made ones, we use quotation marks and put the information there. See how everything cleared up when I did that? I'm going to go through and make sure I don't have any red here. If I have anything red, set precision. I need the IO manip also, don't I? So I'm going to go back to the header file and put the IO manip in here. Okay. So does that address everything? Yeah. Now that IO manip's in here and I've told it to include tele H, it's going to grab everything from tele H and use what it can there, so we don't need to redeclare everything. The prototypes are there. It tells it what to do. Or no, well, we don't even need the prototypes. Here's the actual setups for it, but up here is for documenting. We'll document it in a second, be a little bit more clear. What we got to do is come over to source now. I can delete that. And I need to tell it to include my tele header. Okay. And look at that, all the errors went away. Now look how short my main is, 50 lines. And if I get rid of some of the extra spacing, it'll actually look like 50 lines. 50 lines. So I've got my programs nice and neat. I have files where I can go through and they're all shorter than the main also. And I can go through and find what I'm looking for if there's errors. This one's got two things. If you just click save, it's only going to do the one you're doing. If you do the one next to it, it'll save all. All the ones that have these things that have asterisks next to them have not been saved. So if I click save all, it should save them all. I'm going to come over here and I will run the source and we'll show that everything works. There we go. Took a little while to run, didn't it? It does take a little bit longer to run because it does need to load things, but generally not a lot. Notice I have my IO stream, my string, my IO manip over here. Let's just come over here and get rid of those. I don't need that there. I don't need my string. IO streams in the other one. My C standard library is in the other one. Is C time and do I need C time in the other one? I don't see any math here in this one. Was there any C or math in these? Maybe I included C math and I didn't need to. I got square root. I wonder why. Oh, yeah. Visual Studios is automatically loading C math. Damn you, Visual Studios. Not all compilers do, and you shouldn't assume that the file will. So I'm going to move my C math over there and save all. And all the random was in here. Do we even have random? No, there was no random. I didn't even need the random in there. So I don't need to see time. And now basically all we have in our main file, I'll put this at the top. I've included my tele, and vector is in the main. Vector was not in any of the other ones. Vector's here. We're not going to put vector in tele because we don't want to assume that they want to use it. So it stays here and everything should run as intended. Everything's runs. I have forced some stuff on them by doing this using namespace STD. So maybe not everyone wants to use that. Maybe we could go in and edit our C out so that we don't need to. I can come over here, I'll comment this out so it doesn't appear. Hit enter and come over here, and now everything that's got a problem will say so. We can come over here and do our STD : : So we scope it to the standard namespace, and we'll put it in front of anything that's red. This makes it, and this is why you see when you look up some of these codes that you look up, you see this STD : : It's making the assumption that not everyone wants to use namespace STD, so it doesn't force it on them. I got an end line right there. Got an end line right there. Those are just returns. And if I come over to the main, do I have any COUTs over here? Oh, I do. I have one COUT. If I do that right there, we don't have, oh, comment that out. I don't need using namespace STD because now I'm not using STD anywhere. It's all put in the code. Oh, what happened? Maybe there's more in STD that, let's put that back in. Try that again. What broke? I've got something missing over here. Where's the top error say? Oh, some of these other ones are in the standard namespace too. I'm going to turn that back on. The point is, you can turn some of that stuff off, especially if we don't have a lot of stuff in here. String is in this standard, I think, so that's what was the problem. Yeah, brand and stuff like that. And I didn't want to go through and put STD in front of all the strings, so I'm not going to. We'll turn it back on, but you get the idea. I'm not expecting you to do it. There will be one lab assignment where I want you to turn in more than one file, other than, and it's lab 10B, where you're going to take your triangle class, or not 10B, 11B, where you're going to take your lab from 10B and split it into multiples and upload those files. Lab 10B was the triangle one, triangle and point. So I'll have you do it once, but other than that, you can keep doing your programs like this. I'm pretty sure Redden, I know Redden is not going to need you to separate them, but you need to know how to do it. You need to have seen it. And I will continue to separate them in the future for the rest of this class while we're making stuff. But you only really need to do it at the end when you know how everything works. So it's easiest to do at the end. Clean this up a little bit. Come through here. I'm going to make sure everything makes sense. I think I named my units pretty well. Maybe units isn't good. Maybe I'll call them units measurement. Now, where else do I have units in this thing? Gotta be in my set. And my get method needs it too. I don't know if it's referenced anywhere else. If I did my code right, it's not. Let's save all and hit it with a run, just make sure. Okay. So I might put something in here that tells people, anyone that's using it, this is for storing info about televisions. Anybody that knows televisions know what the diagonal is, the measurement, how they measure TVs. Refresh or makes sense. Anybody that's doing in the inventory knows what a SKU number is. I think those are all pretty well named. This will tell users that it does a see out rather than it displays it to screen. There's ways to display or print, save the file, stuff like that. You'll work on that in CSCI 2. This will see out TV properties to screen. And total pixels when we did it was for the entire screen. It generated megapixels, I believe, what we ended up having. I'll come over here and verify that real quick. Yeah, we divided by 1,000,000. So it did megapixels. All right. So add descriptions of what you need. You know, this is the width of the TV, the screen width. This is the screen height, not the TV height. It's always a little bit more from the frame. And we've labeled our units in here or our arguments well enough that anyone that compares them with the list of parameters will have a good idea of what they're going for. Anyone can open this up and go, okay, this is televisions. It tells me it's televisions. I've got some constructors that are set up that are good. I can see my set methods and my get methods. They tell me what they're returning, what their inputs are. And like I know display property doesn't return any text, so all the C outs are inside of it. I don't even need to see the actual implementation to know that just by looking at this. So that's the idea there. That was just doing one class. Now, I used the same class name as in here. You can change it. Like if I call this TV, and I call this TV, first off, the TV thing gets mad all of a sudden because it's telling it to look for the wrong thing. I can come here though and alleviate all those problems by doing this. Changing this to say TV also. Now it's all working. So it's possible to name them something different, but it's not advisable because it's normal etiquette to name the headers and the resources after the class or structure, whichever one you're using, preferably classes for privacy. That way, anyone that sees the header file name knows exactly what the class name is that they have to use in their main. Okay? So that, like, by doing TV, all of a sudden they might want to put TV here, and that doesn't work. There is no TV class. So ideally, you don't do that. I'll change this back to telly. I will change this back to telly. I mean, it's doable, but it's bad juju. Oop. It's trying to run it. All right, I think I fixed them all. Quick run to check. Okay, still working. All right, so that's the TV one we made. I'm gonna come over and do one of our students' labs. This was for the point and segment problem. So we've got two classes here. I want to show you how to do separation when you have more than one class. So I'm going to create two header files, one for the point header file. And we will add a new segment header file, was the name of the other one. And we'll do the same in the resources. So we'll add new resource files, also the same thing, but we use, remember, these are C++ files. And we're going to name them after the name of the class that we're using so that people know what they're getting when they open it up. Okay, so let's strip mine this down. Let me put the header files first after the source. I'll put H with H, or point with point, and segment with segment. That sounds good. We're going to start with point because segment depends on point. So I'm going to come over here and I'm going to grab point and put it in the point folder, the point header. Again, prototypes go up here. And the implementations, let's see, let's make sure I get them all. These are all points. Oh, good. These are all kept in it together. Good job, whoever wrote this program. I knew who did it, but I didn't want to call them out or put them in front of everybody else. I will cut this and put this over in my point CPP. I'll put some lines at the top so I have room to include. Then I'm going to come over and grab, oh, there's a couple more points. Did I move some stuff that I didn't need to? Let me go and check. Point. Okay, all points. These must be the methods. What am I doing? Oh, it returns a point. Scrub. I was going to come over here and go in here. We'll grab the other segment ones. Look at me not paying attention. And we will grab the segment header files, or the segment prototype stuff, and move that to segment. All right, so I'm going to save all, make sure everything's there. And what I'm going to do is I'm going to go through and start with point because I know segment relies on point. So do I need anything in here? I've got chars, I've got doubles. Nothing's lighting up red. It doesn't look like I need anything there. So let's check the point CPP. Oh, I got display though. So I'm probably going to want to include my, I need to include the point file here. Remember, we can't use the arrow brackets. We got to use that. And that cleared everything up except for the C out. So all I really need in this one is include IOStream. And C out is also in the namespace. But it's, since I may not need it, I'll just put the STD and I won't include it yet. It doesn't hurt to have it in there. If I end up adding namespace later because I need it, it's good. I just put it in there in case I don't. All right, those two are looking good. Now, I have IOStream here. Segment needs point. So my segment files need the point file. So I'm going to include the point header here. And since I have the point header here, I don't need the IOS to include the IOStream here. As it's in point already. So anything we've already put in the other one, we don't need to add it here. Let me check the segment, see if there's anything in there I need. I need to include segment H over here. So we got to go through and make sure each thing is including the right appropriate thing. I don't need to include point here because segment H includes point over there. So I don't need to include it here. I just include the header file that it goes to. And I have COUTs here too. So I'm going to put them in. It doesn't make anything not work if I have them. And then I'm going to come over to the main. And I'm going to include segment. And it doesn't hurt to include point, but this one is not necessary to run. It's just here to let anyone know that reads the program. Reads the program or tries to modify it, that there's points involved. Okay, I think that might have done everything. Let's see if this method works. I got to save them all. So it generated 3 points. It demonstrates the segment class by showing where a segment starts and ends and gives me the length. Everything's running good. So this file would be separated. And we want to keep it organized where the header files are all together. And thankfully, Visual Studios does that. Resource files is listed here. We put all the resources there, only source files here. You're going to do the same thing for 10B. This was the 10A assignment. You're going to do the same type of thing with your 10B assignment when you get to 11B. And when you need to upload them, If you're not sure how to get to where you're going or where your files are saved, you can click on or right click on solution module or the solution thing where you got it, and say open folder in File Explorer. And I do that, and it opens the file, and I can go looking for my folders. And there they are. Look, they're all in the same folder here. Although they show as different folders here, a header file folder, a resource file folder, a source file folder, they're all in one file here, which is good. It makes it easy. Okay, and you'll upload those for yours when you get to it. Now, if you're trying to upload something that's not in the same folder, like you wanted to get point H, but it's not in the same folder, the name in parentheses is the file path and name, if different from where we're at, from the current folder. So it's handy to have them all in the same folder. If you're working on a big project with another team, you work for, I don't know, From Software. That'd be cool. If any of you ever work for From Software, I need to know. This is something David needs to know. Like, you better fucking find me, email me. I don't care if I'm not at COS anymore. If I'm 83 and retired, you need to find me, email me, send me a postcard and say, I work for From Software now. Okay?
Got it.
That includes any of the major ones, but Dark Souls and that, those are my favorite brand or favorite games by a long shot. So here you would do that. So that might mean doing like, it's in the C drive and then it's in Windows, following the file path. Here, I didn't need to do it. It's in the same file. Okay.
So when you went to include there, you could pull it straight from your file location?
Yeah, since when we looked at the folder, that's not it. When I look at the folder location, where is it? Open file. It goes, okay, where's the source file? The source file is the one that's using it. And also, is the H in the CPP program in the same file? Since we want to use source and their source uses point segment, ideally we have them all in the same folder. It makes it, and Visual Studios will do that for you. If you decide to do something crazy, you got some more work in getting the file path name.
Will most compilers do that?
It depends on the compiler, I would imagine. But can you, okay, so let's just come back here and look at this PC. And I've got a bunch of folders all right there, but let's just say it goes into C. Is it going to want to look through all of this crap here to find the one file that says point.cpp? It's not going to want to do that. So you'll either want to have them in the same spot, or like if it's just a little more to it. Generally for now, until you become like a real programmer, not like a student or something like that. When you start doing more, you'll start getting into it and you'll know how to find this stuff.
Okay.
Okay.
Yeah.
That's get you started on the separations. That's not all we're doing today. So I'm going to come back over here to the source. I am going to comment all this stuff out. Oh, wait. I'm going to uninclude everything I didn't need. I didn't need the IO stream because that was in point, right? So everything's there. I don't need it. I'm going to comment this out to go over something else. Your lab 11A is on sorting. So like, let's reason out how to sort. Actually, I'm going to delete this because that's someone else's code. And since I'm going to upload this file later on, in fact, I'll go through and delete the other stuff later on. I don't want to upload the students' homework and use that as the lecture notes. So let's talk about sorting. So to do that, we're gonna do a picture. So let's say I've got int x and y. And x, let's just say it stores as 10. And we got int y, and right now it's stored as 7. And I want x to equal 7 and y to equal 10. So I want to switch these. Any ideas on how I can do that? Make you think for a little bit.
Could we use pointers?
Can I what?
Use pointers?
Well, these aren't pointers already. I could make a pointer, but that's not what I want to do. I don't want to make a new pointer. So is there any way to swap these variables? Pointers is a great way of working with it later, and you'll do a lot of changing stuff there, but the idea of swapping even there, you'll find out, follows something along the lines here. Can I go, let's like say in my main, well, these should be in my main. Your variables should be in the main also. But let's say in the main, I say x equals y. That's going to take the y value and put it into x. And then I've got x equals 7, y equals 7. Is there any way to get y to equal 10 now? I can't, like I've got 7 stored in both spaces. I don't know what the 10 is. The 10's gone. I lost it. I killed it. So this isn't working. And if I try to do the same thing with y equals x, then y's value is replaced with x value, and I've got x equals 10, y equals 10. And now my 7 is left. Right? So this loses the 10. This loses the 7. Anything else we could do? Because there's got to be a way to do it. Excel does this shit all the time. Right? It must be doable. Well, the secret here is introduce a temporary variable. Temp works just fine. So now I've got, let's just make a grid and explain what's happening as we do it. This will be my x, this will be my y, this will be my temp. So my starting values, my default values, I've got a 10 here, I've got a 7 here, and this is empty. So what we're going to do is we'll go through, and so this is start right there. Step 1, we're going to use temp to store one of the pieces of information. So I can just say temp equals x. And remember, the equal sign is the assignment operator. It's going to assign the value of x to temp. So that's going to put a 10 here, but it doesn't change either of these. Now I've got my 10 stored in 2 places. I can move the 7 over here. So that'll be my next line. I want 7 to move into x. I want x to be assigned the value of y. that goes there. This one's going to go here. If I do that, I've got a 7 here. The Y is still a 7. Temp is holding a 10. And finally, I want Y to be 10. So temp storing it, saving it for me. I can move it in there. We'll make that number 3. Step 3, Y equals temp. So my 7's there. Y is now 10. It's assigned value of temp. Temp is there, and I didn't need any more boxes because I've got the switch I've got. Unfortunately, we're stuck with temp until the program's over. We're stuck with this, but there's no other real way of doing a swap like this. Okay. So let's implement that in C++ and take a look at it. So we make a temp, then we just start. Notice they go in a cycle. If I wrote them in order like this, temp goes to X, then X goes to Y, or I'm sorry, temp goes to X. That's not what I said at all. That's not what it's doing at all. X goes to temp, then Y goes to X, and then temp goes to Y. There we go. That's what's going on. So we're going in this loop. So let's bring that over here and just show it. So I'll say int X equals 10, Y equals 7. And I'll make a new temp. Yeah, I'm going to use temp. Let's just do a little quick C out. X equals X and comma Y equals Y. Just make sure that's working before I go on, before I actually do the swap. Yeah, okay, that's working. I think I got a little, like, it looked like I had extra space in there. I do. So now I'm going to do that thing. I'm going to make temp equal X. Then I'm going to make X equal Y. And then Y equals temp. And now I'll redo this. And we can show that they switched. 10, 7, and now it's 7, 10. So we've gone through and swapped them. So what if we want to do more than just 2? Like, let's say we have an array. Let's say we have an array. So I'll say constant size equals 7. Please start doing these. Make this size thing here. Some students are like just using 7 throughout the whole thing. And if you want to change the value, you have to change it in a bunch of places. If I declare the size a constant, I can use it in for loops and an array. So how do I generate an array of integers? Say I call it my array. What do I have to type? This is a little refresher problem for the end of the year. Anybody?
Type just to like create the array?
Yeah, just to create it. We're not populating it yet.
Uh-oh, the brackets and just size, right?
Yeah. All right, so now we can use that. If you do this, it makes it easier. Sometimes it might even be someone in here, although I don't think so. People that I've seen where they have an array of size 5 and they're doing I equals 0, I less than 6. Well, yeah, 5 is less than 6, but since you have I equals 0, you're actually doing 6 entries, not 5. If you stick with 0 in size, this 4 little part never changes. You use that same thing every time. So let's make my array size I array. So how do I do that? Let's say we want it between 1 and 100. What could I type here for 1 and 100? Ooh, challenging questions arise. This is what happens when you show up to class. I get to grill you. The open participation thing. What should I add here? What's the thing that generates random numbers?
The
Rand mod.
yeah.
Yeah, rand, and then we do the parentheses. We do mod. We're gonna say the size that we're looking for, and it helps to. This does 0. This will do 0 to 99. So to make it 100, we're gonna do 1 plus that. That will populate them all. Then I can make a for loop and print them out to screen. Let's just do a C out. C out. Let's see. My array, or yeah, my array. Why not use the same name? Bracket. And then I'll make it say the I. And then I'll do another part and I'll say end bracket equals dot. And we'll throw in an end. Will that be too annoying? Let's see. This is just, we haven't done any sorting yet. So it's generating random numbers. I think I want another space in there. I'll put another space after this one. Is that working the way I want it? So it's still the same numbers. This isn't random yet, but for testing purpose, until I make sure I know my sorting routine works, I'm not going to institute random yet, or the actual, I'm not going to seed the random number generator. We'll do that at the end. So we got the numbers. Let's try doing a sort. So if I want to replace, now I've got my array is 7 long. And shit, let's run it and see what that value is. The default values, we'll just pull them up real quick and write them in the picture. Since we're not using the actual seed to make it truly random, these numbers are locked in order for now. All right, so like my swap technique swaps 2 numbers, right? So maybe let's try to sort this from low to high. And I can only sort 2 numbers at a time. Well, I could probably try to do more, but I think that's a lot of work. I think just this simple sort routine, if I run it enough times, it'll get me where I want to go. Let's just see what happens if like if I do this one and this one, if I check these two, this is my array 0. And that one is 1. So maybe I and I plus 1. Does this sound like a reasonable thing to look at? Let's give that a try. Let's just make sure this swap works. So I'm going to copy this, put this down here, and then we'll have our action between it. So I am going to say my array 0, just testing it right now. I'm going to set temp equal to that. I already got temp declared. I don't need to make a new one. I'll just do it here. Temp equals my array 0. Then I will make my array 0 equal 1. And then I make my array 1 equal temp. They're already in the right order, so maybe that's a bad example to do. Let's do 1 and 2. When I look at my values here, 42 and 68 are already in order. So let's do 1 and 2. Let's test it on 1 and 2. This should put it where the 35 is here and the 68 is here. If I just do what I'm doing right now. Hopefully that works. Let's give it a try. I didn't put a space between them. Oh, this should say my array too. And change it. Let's add another. Why do I got 2 semicolons there? How's that not screwing shit up? I think it would. It doesn't. It's like semicolons are cool. It was just a line that had nothing on it. Ah, shit. That looks terrible. I'm not even going to try to read that. Let's just do a quick C out in the middle. There we go. That'll fix it. Okay. Like rather than try to read a crappy display. Okay. So we had 42, 68, 35. I've got 42, 35, 68. So if I know these values, I could go through and sort them and do them all like that. But let's say it's random ones and I don't want to do that. So let's just do a for loop. Let's do this idea in a for loop and just check 2 consecutive squares. So we're off to our for loop. I'm going to bring up my paper again so we can talk some more. So we got 7 squares. I don't know what the values are in them. 1, 2, 3, 4, 5, 6, 7. Let's call it A, B, C, D, E, F, G. There's some number between 1 and 100. So if I want to swap them from low to high, and I'm checking 2 numbers, we're working with my array 0 and my array I. So if they're already in the right order, I don't want to swap, right? If it's already low to high, I don't want to swap. So I only want to swap it if it's higher. The second one is higher, right? If I plus 1 is bigger than I, that's bad. I don't want that. I want it the other order. I want the smaller number on the left. So maybe we should do a test condition. If my array I is greater than, wait, no, that is what I want. I don't want I to be greater than I plus 1. That's the bad one. My array I is greater than I plus 1, then swap. Does that seem about right? I think I like it. What I'm going to do is I don't want to have to do this swap thing every time. So let's make a function. Since I'm doing it a bunch, let's make a function. I don't need a class for it. This is we're just doing a simple function. So like, let's see. Maybe we do void swap. You got int arg1 and int arg2. And that's my prototype. I'll come down here and do a design, implementation. And we're going to do the same thing we did up here with the temp. So we need an int temp. Copy this and paste it down here where I'll change some stuff. I need an int temp. And I could say temp equals X. Actually, if I just do it here, I could just go straight to it, right? I could do int temp equals X. But it's not X in this description, it's arg1. So everywhere I see an X, I'm going to put arg1. And this is my 2. Y will be my arg2. So I can do arg2 here. And let's see. We already knew that works, so we'll comment that out. Let's just test my swap thing here. So I want to swap, not swamp, swap X and Y. You guys think this will work? You think I did it right well? Let's check it out. Oh, I didn't actually see it out. Where's my, I need another C out here. Like I deleted the swap down below and I need it right here. Shit. There we go. Now we'll check it. Gotta make sure it works before we start doing more crazy shit with it. MF. What did I do wrong? Why doesn't this work? I told it to switch them, didn't I? What did I do wrong? Why didn't it? I didn't do anything wrong. Well, the swap function is working exactly as intended the way it's written. What's wrong with my function? Anybody remember? Remember, when we pass stuff to a function, it makes a copy of it in the function. It doesn't affect the original. So if I want to change the original, how can I edit this? We don't pass by value, we pass by oh, making me do all the work. It's just wrong. We want to pass by reference. Pointers would work. Pointers are a little more work than we need to for something simple like this. So we'll just do the address and we'll pass by reference, which means I got to do that up here. And that should fix it. There, it fixed it. So now I know my X and Y, that my swap thing's working. I will comment all that out. We don't need it now. Let's do that with our array. Let's sort our array doing the same thing. So like if let me copy the loop and do that if thing that we were talking about. So we don't want to do the CO. We wanted, what did I write down? If my array I is greater than my array I plus 1. I is greater than my array I plus 1. If that's true, we want to do the swap thing. So maybe I do mean that. I can't turn the temp off. I need that here. That needs to exist. No, I don't. I fucking just made the function for it. What am I doing? Undo, undo. There we go. We will do our swap. We will swap. And I'm just, to make it easier, I'm going to copy and paste and change that. My MF. Probably would have been quicker to just type the damn thing, right? All right, will that work? No, it's not. Got to an error. Stack around the variable my array was interrupted. What did I do wrong? All deliberate, of course, for discussion. So you will have this happen to you when you're coding. If it says stuff like that, is there anything in my error log that says anything good? No, that's old. The problem is when I did my normal for loop, I equals 0, I less than size, it's going from 0 to 7, which means it's covering 0 through 6. The cells are numbered 0 through 6. But when I try to swap I equals 6 with I plus 1 equals 7, there is no my array 7. So I need to say size minus 1. Okay. That should fix that. Now let's see what happens. So it said, okay, so it started 42 was not less than 68. So it stayed the same. Then 68 was less than 35. So it swapped them. It put 35 to 68. Maybe I can do this on paper, try to figure out what's going on. So it checked 42 versus 68. Nothing. Let's list the numbers again. 42, 68, 35, 1, 70, 25, 79. So I checked the first two, no swap. 68 versus 35, swap. That makes this one 35 and this one 68. And we did those two. Now we did those two. Now we're going to check this one. And it's going to check 68 versus 1. Well, that'll be a swap also. So take this, put the 1 there, put the 68 there. And then does 68 versus 70. No swap. Then does 70 versus 25, and it says swap. So we put 25 here, we put 70 here. And then it checks 70 versus 79 and no swap. So if I followed my steps correctly, I'm not looking at the screen right now. The screen should say 42, 35, 1, 68, 25, 70, 79. 42, 35, 1, 68, 25, 70, 79. Okay. So I was able to follow the steps of what's going on. Is the loop sorted? They're not sorted, are they? Still not in order. So, how can I make this keep going? Well, one way to do it is I'm going to make a toggle. Bool, we'll call it is sorted. And I'm going to set it equal to false to start with. Okay. So the for loop is good, but maybe I should do while is sorted equals false. Now I can keep make it going until it stops being false. So maybe at the start of each for loop, I'll set it equal to false just in case. Now, let's see if I need that. Yeah, I kind of do. It'll never stop if I don't. Is sorted, we'll set it equal to false at the start of each for loop. And then in the for loop, if a swap takes place, we're going to say is sorted equals true. So this makes the while loop run again. Now I should be able to run that and have it get to where I'm going. Let's see if it fully sorts it. It did not. Why not? It's got the same things I had before. It only ran once. Is this not triggering? Just doing a quick check to see if my is sorted working. Let's copy that, or I don't need to say it each time. Now let's do it at the end of the for loop. If is sorted equals true, let's say needs another loop. Well, that's the problem. I've got it saying false while is sorted equals true. If it's true, I need to run again. That was what was wrong. Well, shit, it didn't do anything at all. Oh, because it never even ran. We'll set this one equal to true so that it starts the loop. It didn't even run the loop. All right, there we go. So that does swapping. This was lab 11A. This section right here. But guess what I'm going to do? But I'm going to delete it so you can't copy and paste it. So this is the part that does the looping for the homework. This is called the bubble sort. I'll show you in a picture, in a graphic in a second. I'm going to delete it. We'll reactivate these, turn these back on so that they show up in the thing. In fact, but I'll just rename this now. I'll call this swap my array 1, swap my array, swap my array 1, comma, my array 2. So deleted that. This will be what I load. We'll have the swap program where you'll be able to see it as a reminder of it available, but I want you to write your own bubble swap. There are a few types of sort algorithms. You'll be asked to keep count how many swaps you do. So you're going to need to do that. But there's several different types of swaps that you're going to do, that you're going to explore this a lot in CSCI too. So I'll just talk about that for a second. We just did the bubble swap. Or bubble sort is what it's called. Sorry, not bubble swap. Bubble sort is the whole thing. We just did the bubble sort. There's other types of sorts. This is a big section in CSCI too. Why? Why? Because sorting takes time. And some sorting algorithms are better than others. And when I say better, I mean faster. So you will explore this, and rather than trying to use a timer and like doing start time and end time, because time depends on computer processing speed, memory available, it depends on all sorts of things. You'll get different results on different computers. But one thing that doesn't change on different computers is the number of swaps it takes for the same algorithm. So you will track swaps. And track, I mean, keep count. In fact, you're going to do that in your Lab 11A. If we go over and take a look at it, Lab 11A is to do a bubble sort on 20 random integers from 0 to 100. You should do with a regular function, like the swap thing we did. Maybe I should edit this and add a little bit more information. In fact, I'll do that right here while I'm talking to you. You can use the swap array we did in class, or swap function we did in class. The bubble sort procedure should be performed within a regular function that takes the array as an argument. So that'll give you some practice. It takes the array as an argument, and you can either returns the sorted array or replaces with pass by reference the original array. So you'll have some options there. But then you're going to want to keep track of the number of swaps you made to sort the array. And once you got that working one time, then I want you to practice, see the law of large numbers in play. I want you to run it 50,000 times. If you do as I asked, you do a 0 to 100 array, and you do it with an array size of 20, I can tell you that you're going to get approximately 93.07 as your mean average number of swaps. Okay. I did it. I ran it 10 times and they were all right around there. It was like 93.07, 93.0695. They were all rounding 2 decimal places, 93.07. So if you follow along that, you're doing good. If you can get that value when you're done, you know your array is sorting great. Let's say that. Any questions? Are you guys even there?
Yep.
Yeah.
All right, good.
I'm there.
Okay. So that's it for today's lecture. I'll hit stop record.
I had a question outside of the assignment we're going with lab. Well, I was wondering whether or not it would be possible for students, or for like if students could rework on